thank you everybody for joining. I know that there is a ton of content out there that you all are, being inundated with in this time of COVID. And I appreciate you taking some of your time to listen to me to talk about a topic that I'm really passionate about. My name is Chris Riley. I am a DevOps and DevRel advocate at Splunk. Basically, that means that I was a really bad software developer, and now I talk about software development. So my skill is to do events like these and engage with our internal teams to talk about the industry, what's going on, how people adopt DevOps. And the reason I'm so passionate about it is because we are in a state in DevOps where it's largely getting boring. And the reason I say that is we're solving real world problems today. We're not doing the fluffy unicorn stuff anymore. We're really focusing on all enterprises embracing better software development practices. If you're interested in hearing more from me and my various podcasts, go ahead and scan that QR code and we will, you'll get access to all my socials and information. Typically, when you have a conversation about DevOps, what do you talk about? Usually you talk about going fast, acceleration, automation. And that's by design, right? The whole point of this is mean time to value, getting faster value to your customers in a very efficient and effective way. And I think that's fair. I think that should be the general expectation. But is DevOps just about velocity? That's the question that has always plagued me. You can look at one of my first DevOps.com articles, and I talk about this idea that, is it really all just about going fast, or is there something more to it? And so I challenge you to think about this. 4 a.m. Oh my gosh. Congratulations, Pete, for getting on a webinar at 4 a.m. Sorry, I'm looking at the chat. Don't be afraid of the chat box. So I'm going to challenge you with this. Let's say you finally got your chance to drive a McLaren F1. Put you in the driver's seat and they say, go. All right, go. And you ask, where's my helmet? Oh no, you don't get a helmet. What about my safety belt? No safety belt. Gauges? No gauges. And you look in front of you, and the road in front of you is just a dirt country road. Not a smooth paved road, just a dirt country road. So you're in one of the fastest machines on earth, on the road, I guess. Don't challenge me on that. And you're expected to just go down the path and expect everything to be okay. So I don't think you'd be comfortable with that. I think that you would probably want to jump out and call it a day versus trying to go through that crazy process. And that's what we see in most DevOps environments. And by the way, if I turned on this slide and you're like, whoa, pink, that's on purpose. Sorry, we're testing your retinas here. So in most DevOps environments, this is what we see. We see organizations really good at going fast, really good at automating, really good at connecting dots together from a technical perspective. But what they're not so good at is making sure that that velocity can be sustained. Meaning, sure, you can automate today, but what does that automation mean for you in the future? And do you know if your automation is serving you well or not serving you? Because a lot of times you can automate bad things, which makes them even more apparent. If you automate something poor, then you just make it more successful at being poor. And so a lot of organizations will create these visibility silos where the developers are really good at visualizing their thing. DevOps engineers are really good at visualizing their thing. And then once you get to production, you have just a whole slew of monitoring stuff from IT to security to SREs, etc. And so, unfortunately, organizations have not prepared themselves for velocity. They talk about automation and going fast, but they haven't prepared for them to do it in a sustainable way. And that's where we use this term called Code-to-Cloud Visibility. because the first key in making sure that you can go fast for a long time in a very healthy way is to have the visibility of where you're going. Just knowing what's happening on your path, what's happening on the journey from the point that a feature is defined in your backlog to the point that that feature is running in production. And I like to think of it in terms of depth and breadth. So in depth, we have what we're all very used to in the form of monitoring and observability. So you have full stack monitoring, and when something breaks, you use this technology and practice of incident response to make sure that you can mobilize the right person at the right time to triage and resolve an incident. That is widely known and understood. But what a lot of organizations fail to incorporate into this is the breadth. What happens once a feature is defined in all the telemetry created from the point that feature is developed, and you go through CI/CD and testing, and then finally production. So Code-to-Cloud Visibility has to incorporate all of this. I love the comments in chat and everybody saying where they're coming from. Brazil's a lot warmer than what I'm facing here in Colorado. So why? Why does this matter? Well, obviously, I told you, you want to go fast, right? You want to be able to get into that McLaren and feel comfortable. And that's really it. If you are starting today with a 1998 Honda, or I had a 1998 Accord, which is very Acura, which is very, very similar, and consider that your on-prem monolithic application, all the way to the Tesla or the McLaren, which is your cloud native application. No matter where you are, even if you're one of the unicorns, you're always transforming. A lot of times when we talk about transformation, we always talk about it from the old school enterprises moving to the cloud. But even if you're in your cloud, you're always addressing challenges and trying to transform your environment. That's why you need Code-to-Cloud Visibility. You can't transform without this visibility because you can't see where you're going. So you can try to transform, but you're doing it blind. And so that is why it's so critical. And the way we like to look at it is Code-to-Cloud Visibility breaks into 3 dimensions. First is pipeline analytics. Second is DevSecOps. I'm sure that you've heard that term. And as you all know, our industry loves its terminology. And any good curmudgeon will challenge these terms. And finally, observability, which I dare say, and fairly controversial, is the modern form of monitoring. So let's dive into pipeline analytics. Like I said, this is one of the practices that I'm surprised organizations don't undertake. It's actually a relatively light lift. Depends on where you are in your automation, in your collection of telemetry across your delivery chain. But pipeline analytics is essentially the process of collecting telemetry from your delivery chain, from the point that a feature is defined in your backlog to the point that you get to release, and even after, dare I say after, with incident response and data from your incident response platform. Why we do pipeline analytics? Well, first of all, pipeline analytics is the foundation of DevSecOps. So the first 2 use cases of DevSecOps, which I'll cover, you cannot do without pipeline analytics. But you do it because you want to monitor your delivery chain. You want to be able to audit it, to know what's going from a compliance perspective, and you want to be able to measure it. Now, all of these are critical. Monitor, make sure it's up and running. Audit, make sure that you can do compliance without stopping everything for a period of 2 weeks. Measure, make sure you know you're doing good or not. It's all fairly basic stuff. And a lot of it is what we already do today. So if you think of your software delivery chain as your meta application or your application of applications that is delivered to your developers, first thing, you have to make sure it's up and running. Is your CI/CD tool running? Is your secrets management tool running? Because if either of those are down, you're probably not going to ship code anyways, your artifact repository, etc. How we do this is pretty straightforward. You have infrastructure metrics and your standard application metrics. We already know how to do this. We do it in production. The second component of pipeline analytics is auditing and compliance, usually the one none of us want to do. But if you build it into pipeline analytics, you can be doing it in real time. It follows your automation so that it doesn't disrupt your automation, because otherwise, if you're in a large enterprise, the compliance team is going to come down to you and say, stop everything until we figure out what's going on in your environment. And that is extremely painful. And the only way to do that is collecting this data, but also sharing the data. The other thing organizations tend to forget is that your software delivery chain is a part of your attack surface. People want to get access to your repos and your CI/CD process to inject malicious code. And that you need to watch. Are you getting access to your repos from outside IPs, etc.? What policies are they using? If everything is root, that might be a problem. Probably shouldn't allow that. So auditing and compliance is a huge component of pipeline analytics. Next, we have understanding the meaning of good. And this is where people usually get the most excited. So yeah, operate, got to do that. Audit and compliance, don't really like that, but wouldn't it be great if it kind of happened on its own? And then finally, measuring success. So many of you may have heard of this thing called the DORA metrics that came out of the DORA Institute. And they are a fantastic starting point. I would not encourage you to consider them a standard, but they are a great starting point for deciding what to measure in your software delivery chain, like deploy frequency, mean time to failure, change failure rate, to know, is your DevOps automation working for you or not? But DORA is not the only metrics. There's also something called the flow metrics. And I've listed some of the metrics that I really like. Agile metrics like say do and work in progress. Incident response metrics like cost of downtime and amount of unplanned work. Amount of unplanned work is huge because that's all about context switching. And context switching is very expensive to an organization. So with pipeline analytics, you can actually quantify that. That's pipeline analytics. Now let's dive into DevSecOps. So if you're a good curmudgeon like me, you hear the term DevSecOps and you grumble a little bit. Let me tell you my strategy for terminology. And this is true for observability, all the terms out there. I adopt it when it talks about a real problem space, and the problem space is significant enough that you need a term so that everybody's on the same page. You could argue that DevSecOps is not quite there yet, but it is absolutely critical. And you've watched the news, so you know how critical it is. One of the things that I think people make the mistake of when they talk about DevSecOps is they talk about it as if it's a thing that you do or a product that you use. It's neither of those. DevSecOps is a practice. Inside of the practice, there are 3 tactical things that organizations do and have to consider. First is building more secure applications. How do you make sure that your code is more secure? Second is securing the software factory. This is the one that's been in the news the most as of late and kind of freaking everybody out. And it's absolutely critical. Your software delivery chain, your tools in your software delivery chain are a part of your attack surface. And then finally, securing applications in production. You could argue that we're kind of very familiar with this and we could always do better, but that's the area we have most familiarity. The reason we talk about DevSecOps as a practice and something that we need to think about is that we want to integrate security throughout the software delivery chain, from the point a feature is defined to the point that it's running in production. We want to shift security considerations left, closer to when code is written, because if we can catch problems there, it's going to be a lot less impactful than otherwise. But there is also this idea of continuous validation, continuous verification as well, which is a very kind of bleeding edge use case. Security is not an island in its own in production. Most people think about security starting after the application has been released. The idea is not that, a lot of people think of security as the Department of No. The idea is not that. The idea is that the security professionals have confidence and understanding of what's happening in the delivery chain such that they don't have to interrupt the process, so that we are moving at the speed of DevOps or maintaining that velocity. So now, to David's point, which is actually the question about the human problem, the human challenge. That's always a challenge. It comes up in all my, most of my talks, and it's the one that we all know is a problem. We all know culture is a problem, but there is no like playbook for culture. There's certainly strategies though. And some of those strategies are leaning in on the things that are most interesting to the software delivery chain. So if you are a security professional and you're concerned about DevSecOps practices, my tip would be to look at pipeline analytics for measuring the success of the delivery chain first, because you're adding value to the development team. You're giving them an opportunity to measure their success, which at the same time is getting the telemetry and the data you need to visualize things around access to the software delivery chain. And so there's often this give-get process, and you have to start small. And so I think that people challenge, David, as you already know, is a tough one. And we're all salespeople, whether you think you're not. we all are. We're all playing a sales role at some point. But helping people do better at their job tends to really open possibilities up. There's a very large clothing manufacturer out there who has a huge retail presence, and they do something really cool, which is bug bounties and hackathons with their developers. And those seem to be very successful. A lot of work to put those together, but very, very successful in building that rapport and relationship and showing the value of bringing security into their development practices. That's great. So more on DevSecOps that I want people to understand is that it's not a one size fits all. It's a practice. There's a lot of personas involved that should be involved. Your customer is the software delivery chain. Don't think of your customer as a specific role or organization. Your customer is the software delivery chain. It is the factory that produces code. And not only is it not a one size fits all for personas, it's not a one size fits all for technologies. So in the first two use cases, building more secure applications, pipeline analytics is the foundation. For securing the application factory, pipeline analytics and potentially your SIEM. Doesn't have to be, but it certainly would help if you have SIEM and SOAR technologies. God, the acronyms, they're so bad. So bad. By the way, if you ever catch me on Twitter using O11Y or saying OLI to represent observability, then call my bluff, and yeah, I'll owe you $5 or something. That could be dangerous. And then finally in production, you have your SIEM, observability, and incident response. They're in production. I do feel like these really are required technologies and capabilities to make sure that you are securing those applications in production. So speaking of OLI, O11Y, observability, let's talk about observability. Again, observability, it's the hot topic right now, and there is some controversy about what it actually means. Well, I think that there's several dimensions of observability. I don't think it's one thing. Most of the organization will talk about observability as the data, traces and spans. But if you look at it as only as data, you're going to hit a wall very, very quickly. I think about observability as being the modern form of monitoring that takes in all the considerations and the complexities around modern applications, microservices, distributed, stateless, serverless. All of these things are new complexities that we didn't have when the log was our only destination to troubleshooting. So it starts with the data. There's no doubt. If you don't have the data, you can't observe it. But it also means full stack monitoring, and it also means you have a practice of a lot of capabilities, not just one around traces and spans. So let's start with the data. First thing with data is you got to get it into your platform. We are really big on open telemetry. We think that open telemetry democratizes the number one most important first step in any monitoring practice, getting data into your monitoring tool. And open telemetry has a lot of other capabilities built on top of it, such as redaction, sending data to multiple destinations at the same time, that make it extremely powerful, especially if you're a large enterprise where scaling agents can be problematic if your agents are proprietary. Next thing, you have to make sure you have the right data, starting with your metric data, metricized logs, and finally traces and spans. Traces and spans are key to microservices-based applications, but they themselves are not observability. And that's where the controversial bit may come in. And then finally, data resolution. You have to make sure that the data you're getting is actually going to deliver value and be able to help you respond to incidents, give you the context you need to resolve an incident. And that comes down to the cardinality, which is such an awful, like, textbook computer science term, but it matters. The depth of the metadata that you can get from your traces and spans. And fidelity. Are you getting all of the data? In particular, as it relates to real user monitoring and synthetics, full fidelity is extremely valuable, meaning no sampling. Once you have the data, you want to think of this as aligning your observability capabilities to your stack. We are used to saying full stack all of the time. Well, we should be saying full stack monitoring as well. Each layer of your monitoring, from infrastructure up to the end user, should be aligned to your stack. So you have infrastructure monitoring, application performance monitoring, and digital experience monitoring, which is a combination of real user monitoring, synthetics, etc. That's your front end. That's where your application meets the user. And these need to be tied to your security practices with your SIEM and what happens in your delivery chain. So how does it all come together? I know that I said a lot of words. That was a word salad there for you to munch on before lunchtime for most of you. Well, it's not just a tool you're going to buy and plop in and you have observability. You have to think about observability. As a matter of fact, the GDI portion of observability is largely an information architecture problem. Like, if you don't know how you're handling tags in your traces and spans, then it's going to be very difficult to be successful with whatever observability tool you use, whether it's a cloud native focused one or an on-prem hybrid cloud focused one, or a combination thereof. So you're looking at a collection of capabilities, starting with infrastructure monitoring and logs. Logs are the destination. Logs are the destination. Logs are where you go to get the deepest amount of data about what's going on with your application. Then you move up the stack closer to your users with application performance monitoring. So you have service maps and you have your traces and spans, so you can get even more details into what's gone on with your application. And then get all the way to your users with real user monitoring to look at actual user transactions. What is the experience of the user? Because we know in modern applications, latency is the same as being down. If you are an SRE, you're not just troubleshooting outages. You have to address the experience of the user as well, because you'll lose customers. Like at the beginning of the pandemic, we had this remote learning application that the content was great, but the performance of the application was such that we unsubscribed. So matters a lot, no matter who your user is. And then finally, when things break, because things will break, you have to have incident response. Incident response is not incident management. It's not your ticketing system. It's tooling that can quickly mobilize the right person at the right time with the right data and context. If they aren't the right person, instead of just always calling that one person, Charlene, who fixes everything always, because she knows how to turn stuff off and on, you find the person who you find the person who is actually on call and the right person based on their historical record of resolving incidents. All of these together are the practice of observability. No one of these tools or capabilities is your observability. All right, so you're at a Splunk webinar, right? And I got to talk about Splunk a little bit. These are screenshots from Splunk, but where does Splunk come in? We really view Splunk as being your CodetoCloud visibility partner. So the company you come to, no matter where you are in your journey in DevOps, in cloud, in transforming into agile, etc., whether you're a unicorn or all on-prem, we are your partner in creating visibility across that and helping you get to the next stage so that you can hop in that McLaren and it's a nice paved road and not a bumpy, sandy road, and you have visibility and you can enjoy your experience going fast in your DevOps environment versus having a very troublesome time in executing.